Good afternoon, everyone. Thank you so much for joining us. We are giving you 2 for 1 with this presentation. We have Alex Yule and Stephen Geissens with Mapbox. Please give them a warm welcome.
Thanks everyone for coming. Hopefully lunch wasn't too intense. We keep the activity level high here with some asset tracking. It's everyone's favorite thing. So we're going to be talking today about how you can architect an asset tracking solution using AWS services and Mapbox. So for the purposes of our talk today, we're just going to define asset as something of value that you might want to pay attention to and keep track of, but something that moves. So something like maybe a smart trash can that's not moving around, that wouldn't really fit our definition of an asset for today. You can still put it on a map and get insights out of it, but we're really focused here on things that are moving around. So how do we actually keep track of where they are and why do we care? That's what we're going to talk about today. My name is Alex Yule. I'm here with my colleague Stephen. We're from Mapbox. So why are we talking about this at all? Turns out there are a lot of devices out there that are transmitting data. The IoT sector right now represents about 8 billion devices as of today, expected to grow to over 20 billion devices by the year 2020. So that's a lot, across a lot of different sectors. These devices are producing immense amounts of data. As of today, about 2.5 exabytes of real-time data are being produced every day. About 25% of that data is coming from devices that have GPS sensors on them, so it's spatial data. All of these numbers are going up over time. So how do we capture this data? How do we make sense of it? How do we extract value from it? And then at the end of the day, make our businesses run better using it? That's what we're going to dive into. So here at Mapbox, our goal is to provide the tools and the structures and solutions to help you extract value and contextualize all of this spatial data as you collect it and add context to it over time. And I like to think about asset tracking as a 3-part cycle here. The most important piece is that first piece. Without collecting the data in the first place, you don't have anything to work with. So the first step is having some sort of data collection device, whether it's a mobile phone running an application that is pulling data from the GPS sensor, or some kind of IoT sensor that you're attaching to your shipping container or your locomotive that has a GPS sensor. So you're collecting that location data and sending it up to the server. So that's the first piece. Once that data is collected, and depending on the richness of that client device, you're going to have an analysis phase where you're adding context to that data. And we're going to talk a bit more about what that means as we move on. But that's where you add value to that data. If it's just a location, maybe you're going to add some other stuff to it. Then you feed that into your business process. You use it to make better decisions, happier customers, and ideally, hopefully, that will lead to more users, more downloads, more activity, which will then produce more data. And so the beautiful thing about this is that it's a positive feedback loop. And as we know, those are hard to come by. It's a thing where the more you do it, the better things get. So the more data you collect, the more analysis you can do, the better your business does, which then leads to more data. So it's a win-win. And each of these 3 phases lines up with a different set of APIs and tools that we provide at Mapbox. So Mapbox is a location services company. We provide a whole variety of different types of APIs and services that you can use to make sense of your geographic data. So during that initial collection phase, maybe we've got a mobile phone that we're using to collect the current position of a driver. In that case, we might be using the directions or matrix APIs to calculate ETAs, so how long it's going to take for the driver to get to their destination. Maybe we want to get the geometry of that route and put it down on a map, or even provide turn-by-turn directions. We also might be doing some geocoding. That's where you're converting from a text string into a latitude and longitude, or vice versa. So we might be using that to allow our driver to search for a location and put that on the map, or to assign a place label, like where is the driver right now? What's the name of that place? So that would fall under geocoding. The border between the collection and analysis phases can sometimes be blurry. It's not always cut and dry, because some things you'll have to decide whether you want to do it on the device or in the cloud. But either way, map matching usually would happen on that server-side piece, because you might have a messy GPS coordinate that comes out of your sensor, and you want to snap it to the nearest road network segment, so it looks nice on the map. So we use the map matching API for that. And then at the end of the day, what Mapbox is most known for is our Maps API. And that allows you to build and deploy beautiful, performant customizable maps that work on any device. So all of the data that we're collecting here, all of that excess context that we're providing here, it's all going to end up on a map so we can see it and make sense of it. And then one of the other nice things about this ecosystem is there are a ton of third-party tools that play really nicely with what we provide. A lot of them are very closely coupled with our ecosystem. So my favorite one is Turf.js, which is an open source geospatial library written in JavaScript. There's also a port for iOS that allows you to do geospatial functions really quickly and modularly. Then there's a few other things that allow you to do crazy high volume, high scale visualizations, things like DeckGL, KeplerGL, where if our out-of-the-box map stuff is too high level and you want to really go bare metal and do GL stuff, GL native, it allows you to do that. So that's like thousands or millions of points all moving around. But those are edge cases. We're not going to get into that today. So these are the different APIs. This is how they map to the different phases. Now Stephen is going to talk about some actual customer use cases, people who've actually done this.
Cool. Thanks, Alex. So it's great to see a list of APIs and then try to remember and think back, well, how do those really fit together? But we have a few customer use cases here that'll help you start to think about how could I make use of these Mapbox APIs and layer them on top. So by a show of quick hands, how many of you have heard of or used Instacart? OK, a fair amount of you. So if you're not familiar, it's a grocery delivery platform. So you can download an app and essentially request that somebody picks up your groceries and delivers them right to you. Instacart uses Mapbox APIs for maps. They use our map matching API, and they integrate these pieces together to add like a live view of where your driver is. So as a customer, this gives you more insight into when you can expect those groceries to arrive. From a business standpoint, they know where all of their drivers are, and this allows them to drive greater efficiencies when they want to maximize, pack more deliveries in per hour. That's more money for the driver. That's more money for the company. And the customer is happier, leading to more customer spending and higher customer retention. A crazy stat that I just learned recently, there's over 20 billion miles of road driven in the US each year by empty trucks. This is a huge inefficiency in the supply chain vertical. So our partner Transfix has this marketplace that pairs up truckers and companies who need to ship goods to fill up that extra capacity. It allows them, the businesses who need to ship the goods, lower cost savings because that way they're able to use some capacity that would have been charged at a higher rate otherwise. And then on the flip side, it allows truckers to really maximize their time on the road. It's a very similar use case to Instacart also internally for Transfix because they add this whole extra layer of transparency to see in real time where these truckers on their platform are. And now this is one of our consumer companies, Strava. Strava maps users' runs wherever they are. So whether it's somewhere like San Francisco, you'll notice that there are a lot of runs that have been completed around water features and parks. But it turns out that this is a common pattern across cultures. This is along the Seine in Paris and along the Thames in London. Strava, in contrast to the live tracking scenario that you saw in the Instacart and Transfix examples, Strava uses Mapbox tools for historical analysis. So you might think, hey, my company doesn't need to watch things move across a map. But if you have a lot of geographic data with historical context, this type of analysis can allow you some deeper insights. Strava, in particular, takes this data of where their customers are running the most and then feeds that back into recommendations, building a more personalized experience for their users. So now Alex is going to walk you through how you would build one of those live asset tracking pipelines.
Awesome. So this is the fun part. I imagine many of you are here to learn how to build stuff, so we're going to get into that now. This is what we're actually going to build or talk about building today. So it's a real-time operations dashboard for a hypothetical company that's doing deliveries. Say we're delivering flowers. In this case, we're starting in the Bay Area where we're based. We want to know at any given point where all of our drivers are, what their current task is, what their ETA and distance are. so that we can, at any given point, see where all our drivers are, make sure they're in the right place. If anything looks off, we can call up that driver and problem solve. And maybe we also want to have this up not just in our HQ, but in all of our distribution centers across the city. So we're going to look at how we actually built this out all the way from the driver app itself through the server pipeline to the client. So at a really high level, this is the architecture. We split it up into 4 phases. First one, we have to actually get those location updates. Once we have the location of the driver, we're going to send it up to our server pipeline, which is going to be a combination of a stream processor, which allows us to handle a ton of incoming records all at once in a sane way. Then we're going to store that state in a database. That database will then be queried by our client application at irregular intervals, and then that will provide that dashboard experience. So each of these 4 phases can be broken down in more detail. These are the actual APIs that we've used here. I just want to emphasize that this is a sample architecture. The real world stuff will obviously vary depending on your needs. There's also a lot of more advanced components that you can integrate into this. The IoT ecosystem is quite rich today with Amazon tools. So we haven't dove into how to do things like use IoT Core here, but those are all components that you could integrate into this type of workflow. However, this architecture is designed, the overall concepts here are transferable. It's a scalable architecture that allows you to track thousands, maybe even millions of assets worldwide, all at the same time. You don't necessarily want to put that all on a map, because that's not super useful to see all those dots moving, but you could if you wanted to. So starting on the left, we've got our 4 phases that we described before. First one is gathering those location updates. In this case, we want to control the entire experience really tightly. We want to make sure that we know that the drivers are getting to the right place at the right time. We don't want them swapping out of our app into Google Maps or Apple Maps, getting distracted while they're driving, wasting valuable delivery time. So we're going to actually use the Mapbox navigation SDK, which allows you to drop in a turn-by-turn navigation experience into the app. We're going to hook into that to provide those location updates. Those updates are going to get sent up to a server via an API gateway. API gateway will then hand off to an Amazon Kinesis stream processor, which allows us to queue up tons of records and scale up and down depending on our volume over the world. Kinesis will then trigger a series of Lambda calls. Lambda is a function in the cloud, a stateless function that we can use to actually do our processing and do the database inserts. Up above there, we've also got S3 for long-term storage, so that allows us to do that historical analysis that Stephen mentioned that Strava does, in case we want to glean insights from our data over time. From that Lambda, we're going to insert the latest state of every asset into the DynamoDB table. Dynamo will then provide a snapshot of the latest state of every asset across the whole ecosystem here. And then we're using a combo of Lambda and API gateway to pull out the current state of those current assets and put them on the map. So I'm going to go through each of these in a little more detail. This is a bit of code that you could use. We're going to be overriding using a delegate method. This is within the iOS navigation SDK, within the route controller. So in this case, the piece that's most of interest here is the data points that we're going to be pulling out. So depending on your sensor, you have access to different levels of data richness. If this was just a little IoT sensor stuck on a railroad car, we might only get a GPS and a timestamp. But because we're using the navigation SDK already, we can pass up to the server the ETA, the start point, the end point, and even the route geometry itself. So we don't have to waste server time or resources later on recalculating all of that. We can just pass it through. So as the driver is moving along their route, this method will get called automatically. The location will get pushed up with all of this metadata and sent to this API gateway. The API gateway will then transform that record, hand it off to Kinesis for the stream processing step. At this stage, the most important thing here when deciding on how to set up the Kinesis pipeline for the streaming data is just not to use a fire hose, because you don't get much control over how the queue is set up and how the lambdas get triggered. With a vanilla Kinesis data stream, we can actually control the queue size, keep it nice and small to keep things snappy. We can also maintain the record order so that the first records that come in are the first ones that go out. When we were first developing this, we tried it out with a fire hose, and we had points moving along the map and then jumping back. You don't want that. You can also use some database checks for that, but that takes more time and money. So we're using a Kinesis pipeline here to really sanely handle up to millions of records coming in every few minutes. Once enough records stack up, it then triggers an arbitrary action, in this case, a Lambda function call. Those stream records get called as the argument for, in this case, a JavaScript function, which will churn through those records, process them, and add whatever metadata context we want. So this is where the heart of our application lives. If we wanted to do fun things like geofencing, like trigger an alert when a driver comes within a block of our supply depot, we could do that here. If we wanted to add in ETAs or directions to a really simple payload that we're getting out of an IoT sensor, we could do that here. And then once we've added all that context, we push it into the database where the current state of everything lives. In this case, we're using a DynamoDB. Nice and simple, no SQL, no problem. You can see our main fields here. We've got latitude, longitude, some timestamps for checking. And then the nice thing is you can just put everything else into a JSON blob and pass it through. You don't even have to worry about it. One cool thing we did here is just encoding that route geometry that we had from the client. We're encoding it in binary using a polyline, which is a nice way that you can really minimize the size of that binary, of the geometry payload. We stick it in here and then pull it out again later on the client. So that last step, the client is going to be making a request. We're going to pass in a bounding box, so we're only pulling in the assets out of the database that we actually need to use currently on that map to keep things snappy. And then we're using a combo of an API gateway and a Lambda to make the query from the database, transform it back into GeoJSON, which is what Mapbox wants to see. That extra Lambda is optional. You can do this just with an API gateway if you want. So we did the first round. This is how you actually spit out GeoJSON using velocity, but it's a lot harder to debug, and it's really more of a headache than it's worth. So we'd recommend that Lambda approach instead if you're going after it. And then that's the whole pipeline. At the end, it ends up on the map. So this is just another high-level view of from left to right, going from the Nav SDK, API gateway, into Kinesis. Kinesis calls Lambda, does the processing. That then inserts the latest record into the database. And then we're using that combo of API gateway and Lambda to pull things out and display it on the final product, which Stephen will talk real quick about right now.
Thanks, Alex. So once we're back to this view, you can see that there's a lot going on, right? You have all these blue dots that represent the drivers moving around. You have the widgets on the left-hand side that have the ETAs and distance to their destination. And this is a lot of state to keep in sync. So we recommend using a state management library like React. So once you do retrieve the data from your devices that's streaming in, your map needs to ingest that. And you can use a variety of methods to make sure that you're keeping the most up-to-date state. We use long polling in this example. You could use a pub-sub architecture, or use WebSockets as an abstraction to make it a little easier to keep that data live in real time. And then once you have that GeoJSON data, you pass that into our Mapbox GLJS library, which is our web-based rendering library. This is a JavaScript library that in a couple lines of code, you can render a map, add a layer with data, and style that data that really makes it either pop for your users, so it's a more visually engaging for your customers, or internally, you can add data-driven styling that gives you some more insights based on the properties of the data. And all of that is rendered on top of our maps that are served up by our Maps API. And those are those customizable tiles that Alex spoke to earlier. Now, in addition to just points and lines, there are a lot of other visualizations you can add using our libraries. Down here is an example of an isochrone, which essentially gives you an idea of how long it would take to get to different points around you based on current traffic and real-time data. And that's all built into our navigation and directions APIs. There are some other APIs that are relevant in these use cases when you're building out these visualizations, like the map matching API that Alex talked to earlier, when you want to make sure that those data points snap to road networks. Some additional features that you can add are like geofencing, monitoring when somebody enters or leaves a specific geographic region. And there are other API endpoints that can make this a much more rich experience. And this kind of all plays back into bringing that data into the pipeline, analyzing it, and then gaining from that analysis some business improvements, whether it's cost savings, reduction in delivery times, or increases in customer satisfaction. So that's our presentation. Thanks for joining us today. If you have any questions We're in booth 2520. If you walk right down this pathway over here, you'll see us down on the left. Thanks.